Okay, so at a point P, the angle of elevation of the top of a hill is 36.3 degrees at a point Q on the same horizontal line P, and the foot of the hill and 60 meters from point P, the angle of elevation is 24.5 degrees. Find the height of the hill. And so we are given 2 points on the same horizontal plane, points P and Q, and their angle of elevation of the top of the hill are given. So there are two angles of elevation. P has 36.3 degrees and Q has 24.5 degrees. Okay, so if we try to illustrate this one, say this is the hill. Okay, the height of the hill is x meters. And then on the horizontal plane, at the bottom of the hill, there are 2 points. Okay, the first point is here, and the second point is here. Now the question is, which is closer to the hill? Is it point P or point Q? Okay, let's look at the angles of elevation: 36.3 degrees and 24.5 degrees. Okay, so based from logic and siguro common sense, we know that the points, with the lower angle of elevation is farther from the hill. Okay, so point P should be here with angle of elevation of 36.3, and Q should be farther with an angle of elevation of 24.5 degrees. Okay, so the angle of elevation of point P is 36.3 degrees, and the angle of elevation of point Q is 24.5 degrees. Okay, so the distance between the 2 points P and Q is given at 60 meters, and we are solving for the height of the hill, which is represented here as x. Okay, so the other dimension that we do not know is this dimension from the bottom of the hill to point P. Okay, from here to here, we do not know the measurement, so we also let that be a variable, say y. Okay, so basically we are only looking for the value of x because we are finding the height of the hill, but apparently there is another variable y that we need to solve. Okay, so there are two right triangles in this case. The bigger right triangle, this one, this is the bigger right triangle, and the smaller right triangle. So based from the two triangles, we can actually formulate two equations. Okay, so considering the bigger triangle in this one, let us consider these two sides, 60 plus y, and then the other side is x. Okay, so this side from point Q to the bottom of the hill is measured to be 60 plus y. Okay, so we are given an opposite and an adjacent side. Okay, so we will use the tangent function to formulate our first equation. So tangent of 24.5 degrees is equal to the opposite side x and the adjacent side 60 plus y. Okay, so that is our first equation, and then our second equation will be based from the second right triangle, a smaller one. We also use the tangent function since we are given side x and y. So tangent of 36.3 degrees is equal to the opposite side x over the adjacent side y. So we are now given two equations and then we are asked to solve for x. So to answer this one, we need to solve this one in terms of y. So y is equal to x divided by tangent of 36.3 degrees. Alright, okay, and then we substitute this one. We substitute this equation, the value of y to the first equation. So the first equation now becomes tangent of 24.5 degrees is equal to x over 60 plus x over tangent of 36.3 degrees. Okay, so okay, we can solve this one. We can solve for x. This is, so this is, we need to multiply, cross multiplication. This is tangent of 24.5 degrees multiplied by this whole thing in the denominator, that is 60 plus x over tangent of 36.3 degrees, and then this one is equal to x. Okay, x. So we need to distribute tangent of 24.5 degrees, so that becomes 60 tangent of 24.5 degrees plus this is x multiplied by tangent of 24.5 degrees over tangent of 36.3 degrees, and this one is equal to x. So we need to solve for x in terms of all the other quantities. So we can combine these two quantities since they contain x. Becomes x multiplied by 1 minus tangent of 24.5 degrees over tangent of 36.3 degrees. Okay, this one is equal to 60 tangent of 24.5 degrees. So x therefore is equal to that whole thing, tangent of 24.5 degrees all over the whole quantity 1 minus tangent of 24.5 all over tangent of 36.3. So therefore x is equal to 72.03. 72.03. Okay, since the unit is meter, this also has a unit of meter. Okay, so therefore our conclusion to answer the question of the problem, the height of the hill is 72.03 meters.